Hi, in this video we're gonna make some repetition, this time on the subject of logarithms. And let's start from the basics. If we define that y equals logarithm with base b out of x, again, just like in case of exponential expression, this is called base. And our base, of course, needs to be either 0 and 1 or 1 and infinity. So, we read this that logarithm with base b out of x equals to y. And this, that logarithms are strictly connected to exponential expressions, because based on what we see over here, we can always construct expression like this. Because look, what logarithm is telling us is to which power I need to take b in order to get x. And the answer is y. And this is what you see over here. To which power I need to take b in order to get x. We see that this power here is y. So those two are strictly connected with each other. Now, so how do we write it, let's just say, less formally? So logarithm, this expression tells you to which power I need to which power? And this power, okay, will be is our y. I need to take the base. And the base, of course, is our b. In order to get x. Okay, so let's do a couple of examples, and let's relate those examples with exponential expressions. So logarithm with base 2 out of 4 is equal to 2, because 2 to the power of 2 is 4. Now, logarithm with base 1 over 2 out of 2 is equal to negative 1, because if I'm going to take 1 over 2 and raise it to the power of negative 1, I'm going to get 2. Then, logarithm with base 1 over 3 out of 9 is negative 2. Because if I'm going to take 1 over 3, take it to the power of negative 2, I'm going to get, look, first, if I'm getting rid of the minus, this is simply 9. Okay, so two more, actually a couple more. Okay, logarithm out of 4 with base 4 out of 64 is 4. Oh god, sorry, it's 3. It's 3 because 4 times 4 times 4 is 64. So we've got 4 to the power of 3 is 64. Okay, so now let's get into more interesting cases. If we've got a log with base 7 out of 1, the outcome is 0. Why? Because 7 to the power of 0 is 1. Okay, and how about logarithm with base 6 out of negative 6? The answer is There's no answer. There's no imaginable power to which you can take 6 and get negative 6. You cannot take positive number into some power and obtain a negative. So this is a little trap, but we do not have the answer to this case. Okay, then we've got the logarithm with base 2/3 out of 0. And again, what do we see over here? Not a possibility. Can I take 2/3 to some power against 0? Impossible. So these two examples should allow us to make one additional assumption that we should take. This time on the argument x. X needs to be bigger than 0. This should ring you a bell about the connections the logarithmic function has with the exponential function. But about this a little bit later. For now, let's just do an example, simple example of how to draw a logarithmic function. Okay, so we will use again a very simple example. Logarithm with base 2 out of x. Okay, and again, we can start with the table. And let's just see. -1, 0, 1/16, 1/8, 1/4, 1/2, 1, 2, 3, I'm sorry, 1, 2, 4, 8. And well, the next should be 16. Okay. The first two cases, right away we should notice impossible, right? Remember, x, domain of x starts with numbers above 0. Okay, and so now let's start from the middle, just like we did before. To which power do I need to take 2 in order to get 1? Well, the answer is 0. To which power I need to take 2 in order to get 2? The power is 1. To which power I need to take 2 in order to get 4? The power is 2. The next one will be 3. Next one will be 4. Now, to which power I need to take 2 in order to get 1/2? -1, -2, -3, and -4. And I hope at this moment you can see the pattern that emerges from that. So now, if I want to draw a logarithmic function, what should I do? X, here is y. So, first thing, we should remember that here we have an asymptote. The function will never be touching 0, never will cross this axis. And now let's put some values. Well, definitely 1, 0. And like, look, what is happening over here? In order to get 4, oh, I'm sorry, 2. Yeah, 2. I'll raise it. I get 1, right? Now, 4. Now, in order to transform 2 into 8, you take it to the power of 3. Okay, actually, this is all that we're going to draw. to 1 over 4 to the power -2. And of course, if I would like to take it to the power -1 over 8, okay, somewhere over here, power would be -3. Now, if I connect all those dots, hopefully it's going to produce a nice shape. Again, I'm sorry, it's okay, it shouldn't look like this. Let me fix it a little bit. It's really hard to draw without a computer. And the shape should look like this. And I hope you can see one very important feature. Look, this function is actually rising slower and slower. Look how steep it is over here. It rises very, very fast. But it slows down. It's slower and slower and slower and slower. And even though this function increases to infinity, so it never stops growing, the growth of this function is slower and slower and slower. So basically what we get here is a concave function that is increasing but at a decreasing rate. Okay, and now let's see what happens if instead of logarithm with base 2, we will have logarithm with base 1 over 2x. Okay, again, let's do the table. Definitely nothing here. What do we have here? In order to which power I need to take 1 over 2 in order to be 1? 0. To which power I need to take 1 over 2 to get to? -1. Here, -2, -3, -4. And now I hope you can even guess or remember this. Here we will have 1, 2, 3, and 4. So look, very similar thing happened to us with exponential function when I turn the base from from 2 to 1 over 2. Yeah, like everything here reversed. But let's see what are the consequences of it on this graph. Look, what we have here is that for very small numbers, like when x is 1 over 8, we get 3. For 1 over 4, we get 2. For 1 over 4, we get 2. For 1 over 2, we get 1. And then to 1, we get 0. Now, over here, for 2, I'm having -1. For 4, I have -2. For 8, I have -3. Again, if I connect all those dots, and with some luck, let's just say in drawing, I should get a shape. Okay, sorry, give me a second. This is not my best work, but I hope you can see it over here. That here we have. What we've obtained here is a mirror reflection of this function, but this time the axis of symmetry is horizontal axis, the x-axis. So everything that you see here is a mirror reflection of what you see here in the other function. So look, again, we've stumbled on this symmetry. And on the symmetry over here, and the symmetry comes from the fact that we've turned 2 into 1 over 2. Now, this has very important implications for us, and it shows us in another way that there is a very strong connection between exponential and logarithmic functions. But this is the topic we will we will deal with in next videos, because before we get into it, we want to have our exponential functions and logarithmic functions in very specific form that will allow us to calculate derivatives very easily. So of course we need to go back to the E number, and we will in the next video. Okay, thank you for your attention.